Hey folks, very good evening and thank you for joining in early. Like I started seeing a few questions in the chat window and I thought I might as well join a little early and answer these questions before we go into the live session of problem solving itself. All right. So again, I have all of the comments on my chat window on my phone here, so I'll keep looking down to look at these comments. Hey, good evening, everyone. So we'll spend about 5-6 minutes and we'll start the session itself at about 7:02 or so. So there's a very nice question from Sandeep in the chat window, which is that he prepared GATE 4 times and his best rank has been 1400 and he's currently a working employee. Can you suggest, is it okay to prepare for GATE one more time? Sandeep, 1400 is a pretty decent rank. I mean, to put it simply, I'm sure all the effort that you have put in these 4 years, I would say, since you came this close to getting a very good rank, if you just put in the effort, some more effort, right? Of course, it has to be focused effort. You should not repeat the same mistakes that you have done earlier, and you should plan and strategize very well, primarily focusing on topics, problems and areas that you know you're lacking and that you know you need better exposure to and better practice in, right? Once you do that, I mean, we have seen students with 3,000, 5,000, even 10,000 rank. Some people who just got qualified didn't get a rank, who got a rank last year and the year before that. So you're this close to getting it. And I think if you put in focused effort for one more year, there is nothing that's stopping you from getting it. You just need to learn from your mistakes in the 4 attempts and be focused in this preparation. But if you think you cannot be focused and give like a full on time and energy to it, then don't do it. Promise yourself that you're going to put in 3 to 4 hours a day, then you're cool. Cool. Will this be added to the actual course playlist? Yes. So we'll add it at the end of the course as additional or optional videos that you can watch shortly. Cool. So this is an interesting question from Rish. How to stay positive with so many negatives around? Again, let's not run away from all the chaos and suffering around. We can't run away from that. But it's also important to see the big picture. And again, it's human only for us to see all the news and get really sad. But I think the more important thing is what can we do and what should we do from our side? Let's do that part. And don't spend too much time on all the negative aspects. While we should recognize that something is really wrong, and we should, like, for example, my duty that I try to do is I try to completely lock down, and we have like a strict lockdown that we self-imposed on ourselves, right? Of course, it comes with additional chores, all of that stuff, but that's okay. That's a little price that we are paying. So I do watch news regularly. I try to keep myself abreast on what's happening, but then I don't delve too much into it because apart from this, I don't know what else can I do to reduce the suffering of others because I'm not a trained doctor, right? So give it time, recognize that something is wrong, but don't spend the whole day just mourning because that won't help you personally. And of course, you stay safe and make sure your family stays safe. Cool. Very good. How many marks? So Raghav says, how many marks should you get for under 100? I think, I don't remember the mark at the top of my head, but I think 70 plus should get you there very comfortably. I think even depending on the hardness of the question paper and things like that, probably even 68 could get you under 100. I'm just giving you ballpark numbers. Okay, cool. Hey, my team also has joined. They're also taking some of these questions. So thanks, team. Sagar, very, very sad to hear that your father has passed away. I mean, it's traumatic. I mean, I cannot even say that I can imagine it. So please spend time with your family now. It's okay. You can focus on other things a little later. It's most important for you to spend quality time with your family, and you should make sure that you are strong yourself. Give it a break. Take some time off. Spend time with your close family members who need that support probably more than you, like your siblings, your mother, etc. And you can come back to GATE prep little later. That's okay. I mean, we have seen people who do gate prep significantly later, start their gate preparation even in September and crack it. Right now, what is important for you is to stay with your family. Gate prep, it's okay. It's not going, because you can write gate next year also. You can't console your family next year. You got to do it now, right? So please spend time with your family. So another question here is, does low 12th class marks matter after good gate score? This is from Harsh. It doesn't matter a lot. Like my 12th class marks are 59.8%. Okay, my 12th class percentage is 59.8 and my 10th class marks are 69.6% and my BTech is 89.8, right? So nobody asked me when I went to Indian Institute of Science or in any other company why I got lower marks in my 12th. I'm not even a first class in 12th, by the way. It really never mattered in the long run. Okay, so don't worry about it. So Manvik says, can you give us, can you shed some light on gate versus GRE? I'll spend a couple of minutes on that because I think I've mentioned this in the previous live sessions. If you can get into the top 50 universities in the US, I mean, they're comparable and some of them are surely better than the top universities in India in terms of research, in terms of curriculum and things like that. But getting into top 50 universities in the US with financial aid is not easy, right? So the amount of effort that you need to put in to get into the top 30 to 50 universities is almost similar to what you need to put in for getting into any of the major IITs. So having said that, if you get into an IIT or IISc, in the long run, it really doesn't matter, right? Whether you got into IISc, IIT or Stanford or MIT. Like I've worked with teammates from a wide spectrum of universities. I've been to placements to all the top universities in the US. In the long run, it's what skills you have and what knowledge you have and what you can do for a company or an institution that matters more, not just your university. So coming back to this question, like I had this question as an undergraduate student myself. I preferred to go to IISc or IITs, and that's why I prepared more for GATE and not so much for GRE, because the cost of education is low and the quality of education that I get is world class, right? And if I put in the energy and learn from the top universities in India, I'm getting the same quality of education that I would get even at Stanford, right? And companies don't care whether you come from Stanford or IISc as long as you have the skills. So in the long run, it really didn't matter for me. Again, if you're getting into the top 50 universities, you can surely consider going to the US if you have the financial resources to do so. US has a slightly different academic structure, more focused on experimentation, real world stuff. If you go to universities like Stanford, there's a lot of focus on startups and things like that. But the top universities in India are comparable in terms of their academic rigor to any of the top US universities. Cool. So Aniket asks, okay, I'll take one more question, then we'll go into the actual session itself, right? Because there are a lot of students here primarily for that session. So Aniket says, what should be the order of subjects for preparation for GATE 2022? Aniket, we have made a video on our YouTube channel, which is how to score 55 plus marks in GATE CSE 2022, where we recommend order of topics, order of subjects based on how easy is it to score in these subjects, and what is the typical difficulty level that you get and how many marks you get from each of these subjects. Again, these live sessions that we're doing, which are interactive problem solving sessions, are also in the same order. We're starting with theory of computation because theory of computation tends to have a significant weightage of marks and it's also easier to score than other subjects. Okay, with that, let's get into it. I'll do Q&A at the end again because it's 7:02. I said I'll start, right? So let me start sharing my screen quickly. Give me a second, please. Give me a second. Okay. Okay, I hope everybody can see my screen and no glitches. Can you please confirm that? Can you please confirm in the chat window if you can see my screen and hear my voice clearly? Because I'll not be visible from here because content matters. Can you please confirm that? Okay, cool. So let's get started, folks. Okay, we might spend about 60 to 90 minutes on this session. So I want to get started first. So this is the first live session of interactive problem solving. We have done something similar last year, which benefited our students immensely. So we are doing something similar here. Some of these live sessions will be publicly available on YouTube. Some of them will be limited only to our course enrolled students. So this is the first session on theory of computation. These are the topics. Again, we have done a video, I think last week, right? We did a live session where we told you about this whole plan. There is a Google Sheet where you can see which live session comes when, right? So please follow accordingly. A couple of important things here before we go in. So we have 8 questions today. Out of these 8 questions, we have 4 MSQs. Last year, out of the 65 questions, we have seen anywhere from 15 to 18 MSQs. That's roughly about 25% MSQs, right? So we are just doing more MSQs because MSQs tend to be trickier. More students tend to make mistakes here. So we have 8 questions. Again, you will see both, you'll see all ranges of problems. You'll see some easy problems. You'll see some medium level problems. You'll see some medium problems with trickiness. There aren't many hard problems here. There are some medium problems with trickiness because that's what GATE is focusing on nowadays a lot, right? So again, the fundamental objective of this is not just to solve these 8 questions. It is to build the problem solving skill. I think I've mentioned this in the other videos that we have put out on our channel recently. The most important thing is the problem solving skill, not the number of problems you solve, right? So what we do in this is we show you, I'll tell you how this works, right? I'll show you a question. I'll give you a few minutes of time, right? So in the chat window, as soon as you have an answer, please put your answer. Okay, if you don't get an answer, that's okay. As soon as, again, here I'm not timing it right now because we are still early in the preparation, right? So let students take time. As soon as a good number of students have tackled this question, the answers can be wrong. That's perfectly okay. Nobody is judging you here. It's perfectly okay. I'll keep making some comments on the answers that I see. Don't worry about it. Please tackle these questions. And once enough students have answered it, I will go explain the solution in detail. Again, I've seen some instructors and mentors who just read the solution. We are not doing it. We are explaining the solution like the way a student would do in a pen plus paper setup, right? This is how I would solve it on a piece of paper. Actually, I solved all these problems in the afternoon and I have actually the solutions right next to me. So I will show you how I would solve it or any of us would solve it on a piece of pen and paper so that you know how to think about it. While solving this, I'll keep pointing to a few strategies. Right? These are very, very important. These are simple strategies that you can employ. For example, in TOC, there is a very interesting strategy, which is to try out various examples. I'll teach you how to do that as part of it because that's how you build your problem solving skill. Here, it's not about just showing you one problem and telling and then reading a typed answer. That's not what we're doing here, fortunately, right? Our objective is to build the problem solving skill so that you can think on your own when you're given new problems, right? Cool. So with that, again, one more very important point here. If there are any errors in the solutions that I'm suggesting, please let us know, right? We will correct it. Again, some of my team members are also there in the chat window. They will comment on it. If there are any errors, again, we are human. I also make mistakes, perfectly all right. If I make a mistake or if my team makes a mistake, we agree to it. Please let us know and our team will comment on it. Some students also ask us variations of these questions. Again, because we want to solve about 8 questions in about 60 minutes, roughly about 60 minutes, we may not be able to tackle each of the variations of these questions that you might ask in the chat window. While our team will try, if there is any variation that we could not cover it because of constraints of time, please email us. Just go to gate.appliedroots.com. You have our email address. Just email us and we'll try to answer as best and as fast as we can. Cool. Okay, let's get started with the first question. Okay, before we go there, one more very important thing. I hope you have seen this. Again, this is a screenshot of a video that I've made in collaboration with the rest of our team. This is a very important video. I strongly recommend you watch it, which is how to improve your problem solving skills. We will use these strategies while solving the problems today. Again, this is not an exhaustive list. There are other strategies specific to subjects. For example, in theory of computation, there is one more strategy, which is try out multiple examples in a systematic fashion. I will show that with examples, right? So there are subject specific or topic specific strategies that I'll also cover in these live sessions. But broadly, I'll keep reusing these strategies and keep coming back to these. Okay, cool. So here comes the first question. Okay, so this is a numerical answer type question. This is medium and slightly tricky. Okay, so please read the question carefully. Put in your answer here, and once enough number of students have put in your answers, I will I will explain the solution step by step. And I'll also tell you what mistakes typically students do and how to build that core skill itself of problem solving. Please tackle it. Again, general questions outside of this, general questions outside of this specific discussion about the problems, I'll answer them at the end. Let's not mix these things up. I promise you I'll spend time on, please focus, as one of our mentors is saying in the chat window, please focus on solving the problems in this session. I promise you I'll spend some time answering your questions at the end of it. Please read the question carefully. Again, one of the most important things is don't commit silly mistakes. And how do you do that? Read the question carefully. Please read the question carefully. I see some of you are putting in the answers and I know you have made a mistake. Please read the question. That's the first. Please read the question and options given. I've seen already like 3-4 people who are in a hurry to get the answer right. Speed is not what we are looking for now. Accuracy is. You will build speed with practice. I see a variety of answers in the chat window. Some people are saying 5, some people are saying 2, some people are saying 3, some people are saying 0, some people are saying 4. How can the number of final states be 0 for a problem like this? Please read the question carefully. The reason this question is tricky is because people don't read questions carefully. Somebody is asking what is W? It's given here, right? W belongs to sigma star, which means W is a string of the alphabet sigma. Oh, I see alternative answers also. 1, 6, 5. Again, I may be wrong. I've solved this question myself. I may be wrong, but I don't think some of these answers are correct. Again, if I made a mistake, please correct me. It's a very nice question where a lot of people will. It's okay to make mistakes, folks. Don't worry about it. Everybody makes those mistakes. I made a lot of these silly mistakes when I was young. I learned to overcome them. Okay. I see a lot of people. Only a very small percentage of you have got it right. A vast majority of you, I think, have got it wrong. Again, I could be wrong myself. That's okay. But most likely. I'm surprised that. Anyway, that's okay. That's okay. Okay, I've seen a lot of people put in your answers. Let me give you some more time because there are so many errors in these answers. Give it one more shot. It's okay. Let's go slow. We are still in the early stages of our preparation. GATE exam is still 9 months away. It's important to get it right. I see almost all the answers from 0 to 7, I think. I've seen almost every number here. Some of you are on the right track. I see a comment from Harsh. You're on the right track, Harsh. Your thought process is correct. Okay, so I think I've seen enough of these answers. Let me tackle it. While solving it, I'll tell you some strategies that you can employ. Okay. First and foremost, read the question carefully. I mean, if you see this, what is the first step that I tell you? Read question and options carefully. That's very, very important. Okay. So I'll keep underlying what is important. Okay. So the minimal number of final states, right? We are looking for minimum number of final states or accepting states. In a minimal DFA, which is DFA with minimal number of states, that again, it has to be a DFA that accepts the below language L. And what is L? L is all the strings W such that W does not contain. A lot of you haven't read this not. That's it. You have lost. I mean, this could be like a 2-mark question and you've lost it. Right? W does not contain an equal number of occurrences of 0, 1 and 1, 0. So what this question, again, whenever you encounter this type of language, again, at the end of the day, we have to design a DFA for this. And it says W does not contain an equal number of occurrences of 0, 0, 1 and 1, 0. As some of you have mentioned in the chat window, the strategy, I think we have also explained this in a lot of our solved problems. Now, designing this language is not easy. A better way to design this, a strategy, a very interesting strategy is try to design L complement. Okay, the complement language, right? Which is all the strings that are not in L, but that are in sigma star. So what is L complement? It's also written as L dash, because designing this is not trivial. So one strategy when designing automata is to think from, so this is one strategy. First of the 0th strategy is read knots carefully. Read the knot carefully. You're missing that. A lot of people have done that mistake actually. Okay. Second, design for L complement. Right? What is L complement? It is all the strings that contain equal number of occurrences. Right? So equal number of occurrences. This not will be negated, which means equal number of occurrences of 0, 1 and 1, 0. So let's try to design that. Let's try to get some of the strings from that language. Epsilon. Epsilon has 0 occurrences of 0, 1. It has 0 occurrence of 1, 0. So it belongs to L complement or L dash. Similarly, 0. Look at this. This is string of length 0. Let's think of strings of length 1. 0 has 0 number of 0, 1s and 0 number of 1, 0s. So perfectly valid. Similarly, 1. There are only 2 strings. Look at this. There are only 2 strings of length 1. There is only 1 string of length 0. So I'm going systematically here, step by step. Now let's look at strings of length 2. Right? 0, 0. Right? Because 0, 0 has 0 number of occurrences of both of these. 1, 1. Right? Will 0, 1 be here? Like there are only 4 strings, right? If you think about it, there are only 4 binary strings. There are only 4 binary strings, 0, 1 and 1, 0. But 0, 1 cannot be in this because in 0, 1 there is 1 occurrence of 0, 1 and there are 0 occurrence of 1, 0. So this can't be here. Similarly, 1, 0 also can't be here because in 1, 0 there is 1 occurrence of 1, 0 but 0 occurrence of 0, 1. So this also can't be there. Look at how I'm doing systematically. The second part is systematically generate strings. I'm just writing all these key takeaways here because you can use them in the next questions that we solve. I know I'm going a little slow, but I want you to build that ability. So you have done strings of length 2. What about strings of length 3? Let's go systematically. 0, 0, yes. 0 occurrence of 0, 1, 0 occurrence of 1, 0. Similarly, what about 1, 1? Yes, 1, 1 is also valid. Now 0, 1, 0. There is 1 occurrence of 0, 1. There is 1 occurrence of 1, 0. Perfect. It is part of L complement. Then look at other things, right? You have 0, 1 and 1, 0. Does 1, 0, 1 work? Yes, 1, 0, 1 also works because there is one instance of 1, 0. There is one instance of 0, 1 as substrings basically, right? So 0, 0, 1, 1, yes, 0 instances, 1 instances. Is there anything else possible? Let's look at it. These are all strings of length 3. Does 0, 0, 1 work? No, because it has 1 instance of 0, 1, 0 instance of 1, 0. Right? There are only 8 strings, right? There are only 8 strings, 8 binary strings of length 3, right? Just let's write all of them. I mean, just to get this is how you can think about it. This also won't work because this has 1 instance of 0, 1. Again, with practice, you'll be able to do it fast. Okay, so 1, 2, 3, 4, 5, 6 are over. What else is left? 1, 1, 0. This also won't work because it has 1 instance of 1, 0, 1, 1. It won't work. 1, 2, 3, 4, 5, 6, 7 are done. There is one string that's missing here. What is that? 0, 1, 1. Oh, sorry, 0, 1, 1 is already done. There is one more string that's missing here. 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0. 1, 0, 0 also won't work because 1, 0, 0 has 1 instance of 1, 0 and 0 instance of it. So these are the only strings that are there. This is how you can make sure that you're not making mistakes. So these strings won't be there. These strings won't be there. Now, since you can also generate strings of length 4, etc. But now that you have L complement, let's write or let's draw the whole, again, writing these examples. Systematic generation of strings for examples is a very, very powerful strategy in theory of computation, especially in finite automata and even in other automatas, right? Cool. So now let's design it, right? So let's start with Q0. Okay, let's start with Q0. Again, we are designing a DFA to accept L complement, not L. We are not yet there for L. We'll come to L in a couple of minutes. This is our automata. It has to accept epsilon. So this is the initial state. So this has to be the final state because it has to accept epsilon. Now let's look at 0. Okay, it has to accept 0 also. Again, I'm trying to, whenever I'm constructing minimal DFA, I try to add states only if they're absolutely necessary. And once I design the whole DFA, I'll try to make sure to combine states and see if it's possible. That's how you do minimization, right? By combining states. We've solved a lot of problems like this in our course videos also. So you are at Q0, okay, 0. So because 0 has to be part of this language, right? So you get Q1. Now after 0, if you have, let's say, okay, if you keep getting more zeros, so if you get more zeros, right? 0, 00, 000, 4 zeros also will be here. So if you keep getting zeros, you'll still be in the final state. Perfect. What happens if you get a 1? This is interesting. If you get a 0, 1, it should not go to a final state because 0, 1 is not a part of this. So this state is tracking that you got a 0, 1 or you got a 0 followed by multiple zeros and then a 1. So this is your Q2. Q2 cannot be a final state now. Now, after you get 0, 1, if again, look at what you have. 0, 1, 0 should be accepted by this machine. So 0, 1, again with 0, you should come back to this final state. Right? If you get 0, 1, 0 followed by more zeros, again, look at this 0, 1, 0 followed by more zeros, that's perfectly okay. It has only one instance of 0, 1, one instance of 1, 0. Right? Again, you have to think carefully, very, very carefully. Okay, so all these are good. But what if the string is starting with 1? That case is not handled here. And in a DFA, I need to have all transitions. For this, I have transition on 0, transition on 1. For this, I have transition on 0, but I don't have transition on 1. So what should happen here? Suppose if I get a string like this, 0, 1, 1, right? 0, 1, 1. This should not be accepted. But after that, if I get a 0, then it should be accepted because 0, 1 and 1, 0. There is one instance of 0, 1, one instance of 1, 0. So I will just mark it here. Because now look at this, 0, 1, 1, 0 is going to a final state. Now just like the way, again, this whole side is constructed when I have strings starting with 0. Similarly, I can construct when strings start with 1. Look at this. If I'm starting with 1, that string should be part of final state, right? Because 0 is here. Sorry, 1 is here, right? So I should be able to go here. Now from Q3, if I keep getting 1s again, look at this. If I keep getting 1s, whether I have 1 or 1, 1 or triple 1, I should keep going to a final state. Very simple logic here, right? Now, if I get a 0, what should happen? Look at this. If I get a 0, what should happen? Then I'm getting 1, 0. 1, 0 is not part of this. So it should go to a completely different state. Let's call this state Q4. Now, after I get, again, see how systematically I'm building these states. I'm trying to add these states only when they're absolutely necessary, right? So when I get 1, 0, I reach this state. Now, if I get 1 again, look at this. If I get 1 again, 1, 0, 1 is part of this, which means if I get 1, I should go to this final state. Similarly, if I get 1, 0 followed by any number of zeros, that should never be accepted. So 0 is here. So look at this. For every state, I have the transitions on both zeros and ones. But remember, this automata, this deterministic finite automata, now ask yourself this question. Can I combine these states? Because these are non-final states. Can I combine Q4 and Q2? No, you can't. Because Q4 is keeping track of 1 followed by 0, while Q2 is keeping track of 0 followed by 1. You can't, again, each state tracks some property of the string that you've covered till now. You can't combine Q4, Q2. Similarly, you can't combine Q3, Q0, Q1. You can try it, right? You can try it using the systematic tabular approach, or even intuitively try it. You will not be able to do it. But remember that this automata accepts L complement, not L. What do we want? We want L. Now, if this is a minimal automata, minimal DFA that accepts L complement, how do I create the minimal automata that complements L? Very simple. Make all final states non-final states and vice versa. So this becomes a non-final state. This becomes a non-final state. This becomes a non-final state. This becomes a final state, and this becomes a final state. Now, what does the question say? The question says the minimal number of final states, not the total number of states, the minimal number of finite states in the minimal DFA that accepts L. Now by changing this, now this automata with Q4 and Q2 as the final states, Q3, Q0, Q1 not as final states, and Q0 as the initial state accepts L. Now how many final states are there? Only 2, this and this. So the answer here is 2. Some of you have answered 5. That's because you didn't read the question carefully, for God's sake. I think you misread it as number of states in this DFA. There are 5 states in the DFA, sure. But the question is asking about the minimal number of final states, not the total number of states. Right? Again, these are the reason I'm focusing a lot on these steps now is look at these steps. You have not read the not carefully. You have not read the question on what it is asking. Read, please, for God's sake, please read carefully. We have seen students who could have easily been in top 100 ranks who messed up because they didn't read questions properly. And the strategy of designing the complement language, the automata for the complement language, and then changing final states to non-final and vice versa is a very important problem-solving strategy with respect to designing automata, right? Similarly, whenever you want to, in the initial days, when you want to get a grip on what all strings are there, or what all strings are there in any given language, just use the systematic string generation. Generate all strings of length 0, all strings of length 1, all strings of length 2, all strings of length 3. That's it. You'll get a picture by the time you do this. By the time you do this up to strings of length 3, most likely you'll get an idea of what is happening. Simple strategies, but very powerful when you solve such problems. Okay. I hope this helps. Again, this is tricky. By the way, some of you are saying this is okay. Is there a problem somewhere? Is there a problem? Again, if you think there is an error, just in the interest of time, we're already 25 minutes into this. If I make a mistake, please feel free to email us. We'll put a comment section and say, sorry, we have made this mistake. This is the correction. Again, somebody is very nicely saying, this is taking too much time. No, if you solve enough problems, you can easily solve this in 3 to 4 minutes, easily. And a question like this most likely is for 2 marks, right? With practice, you can easily solve this in 3 to 4 minutes. Right now, in the early stages of your preparation, what is important is to get the concepts right, to build the problem solving mindset. Once you do it, once you solve a couple of thousand problems, or even just 1,000 problems, you don't have to solve 10,000 or 20,000 problems. You just build that ability, solve a few hundred or even a couple of thousand problems, you will solve these in under 2 minutes. This question, that's why I said, is tricky. Okay, if I've made a mistake anywhere, feel free to reach out to us over email. We'll correct it. Okay. Again, we have that humility to say, yes, we also make mistakes. We are just human, right? We are not gods. Even gods make mistakes. Anyway, coming back to our discussion, here is the second question. Again, there are many ways of solving these questions. I'm telling something that I'm trying to teach a technique that builds your thought process. There is no one right solution, by the way. Okay, here is an interesting question. This is a medium level question. Actually, I would call it easy, but so be it. Again, please focus on the question, please. Read the question. I don't have a timer here, but as we come closer and closer to the examination, we'll have a timer. Today, we don't have a timer. In the last 2 to 3 months, we'll have a timer. Again, there is no one right way to solve. Some people could use, again, some of you are putting in your answers. Okay. Again, this is not tricky. This is straightforward problem. Actually, I wouldn't even call it medium. I would call it actually easy. Again, for some of the counter examples that some students are putting in, like Kirti in the chat window, our team is Our team is trying to answer via chat as we progress to the next set of questions. Okay, again, I see a wide spectrum of answers. Somebody says the answer is 3, somebody says the answer is A, somebody says the answer is B. Okay. Again, just please think about it. In the first question, we took more time because I wanted to tell you these key strategies, which we will keep using through the rest of the session. Okay. Again, I see 3 answers broadly. Somebody is saying the answer is 3, others are saying the answer is 4, others are saying the answer is 5, which is option A and B. Okay, so again, unless otherwise stated, all questions are MCQs. If it's an MSQ, we will mention that. Okay, cool. Let me answer this, okay, step by step. I think some of you are making a slight mistake. I see most of you are saying either A or B, most of you. Okay, let's tackle it. Maybe I've made a mistake, like we should be ready for it, right? Cool. So what the question says, the minimum number of states. The question is talking about states, not final states, not initial states, none of it. Minimum number of states that accepts the below language. Okay, the alphabet is 0, 1. Okay, what is the language? Language starts with 0 and has odd length, or, which means union, right? It should accept this, or starts with 1 and has even length. Let's start designing it. Again, whenever we are trying to design the minimal number of states, there are 2 ways to tackle it. Okay, the shortcut or the easier way to do it is add a state only if it's necessary. Add a state if absolutely necessary. If necessary, only that way, by the time you design, so there are 2 steps here. First step is add a state only if it's absolutely necessary. At the end, try to combine states. Combine states if possible. This is a very simple strategy if possible. This is one way that can be done. The second way that some of you might prefer doing is you design a regular DFA and then you try to minimize the DFA, the standard technique that you see in textbooks and in our course videos. This method takes slightly more time, but this is also a perfectly valid way. I'll show this way, which many of you may not know. Okay, so let's go into it. Okay, okay, so let's tackle. Let me change the color a little. Okay, so I'll use this. Okay, so it should start. So let's start with some initial state. Let's just say, okay, so let's just say the state is Q0. Okay, if it starts with 0. So this can't be final state because epsilon is not accepted by this. Says it starts with 0. So by the time I go to the state Q1, it tells me that it is starting with 0. That's what it is trying to indicate to me, right? It's starting with 0. Now 0 and odd length. So what are all those such strings? Again, brute force generations or systematic generation. 0, it has an odd length. Now what about 0, 1? 0, 1 is even length, right? So 0, 1 doesn't work. There is no other 2 strings of length 2 which start with 0, right? The next one, so it should accept 0, right? So this has to be the final state. Look at what others it has to accept, right? Then 0, 1, 0 it has to accept because its length is 3. 0, 1, 1 also it has to accept because it's starting with 0 and the length is 3, right? So we have to somehow keep in mind. So this represents that if this represents that if this state represents that the string starts at 0 and its length is odd. For even, obviously you need to have one more state. So this state is saying the string is starting in 0, but it is of even length. So whether I get 0 or 1, I will go to the state, right? That's why 0, 1, 0, 0 will not be accepted because it's starting with 0, but the length is odd. So look at what the state is trying to capture. This state is capturing that the string is starting with 0 and it has odd number of characters. This is saying the string is starting with 0 but even number of characters. But from even to odd, if you just get one more character or one more symbol, you get it. So done, right? From here we have transitions from 0, 1. We are designing a DFA, right? We have to be careful not to design an NFA. right? We have to be very, very careful. From here, I have 0, 1 transition, 0, 1 transition here. From here, I have transition 0. I don't yet have transition 1. Okay, so this case, most of it is already handled. Now let's look at this case, the second part, which is starting with 1. So it can be 1 and has even length. Oh, so 1 can't be accepted. Sorry, 1, 0 will be accepted. 1 can't be accepted. Because if you just take 1, it is starting with 1, but its length is odd. So 1 can't be there. 1, 0, 1, 1. Perfect. So let's start with 1. So this is our state Q3. This state can't be the final state, remember. That's important, right? So from this state, I have transitions both on 0 and 1 because my alphabet only consists of 0 and 1. Now from here, again, what is this stating? This is capturing the information that this state, whenever I'm in this state, it implies that my string is starting with 1 and I have odd number of characters that I've seen or odd number of symbols I've seen. So for even, what do? That's it. You get this state like this. So this state says my string is starting in 1 and I have even number of characters. Very simple. Now, if from even to odd, if you just get one more character, it goes from even to odd. That's it. 5 states. Again, every state has a unique representation. If I'm in this state, it means, look at this. This state is my initial state anyway. This state says 0 plus odd, which means my string is starting with 0 and its length is odd. This state is saying it is 0 and my length is even. This state is saying 1 and my length is odd. This state is saying 1 and my length is even. I can't combine any states. You can't combine either the final states or non-final states. Again, you can verify it through the minimization table approach. So what is my answer here? I need at least 5 states. There is no way to work around that. So the answer here is B, right? Very simple. Again, we are going systematically. Again, here also, if you observe, for this, I wrote a sample of strings that will be there. Here also, I wrote a sample of strings that will be here because that gives me the intuition to build it. Again, remember, in the course videos, we tell this many, many times that please draw diagrams carefully. Please draw diagrams like this. For finite automata related problems, please have systematic way of generating examples. Something that I mentioned earlier, right? So this is what we have. Cool. Okay. Oh yes, there are many approaches. There is no one right answer here. Please understand that you can do the E-NFA to DFA through minimization. You can do that. I'm not saying, again, for many of these questions, there is no one right answer. Just in the interest of time, I'm showing one answer only. Okay, so is there a problem in the solution? Is there a problem in the solution? Again, some of you are suggesting some alternatives. So my team is answering some of these. Again, please, in case we have made a mistake, please email us. We will put it and pin that comment and say, which says that at this point we made a mistake, right? So cool. Again, some of you, 1 second, let me just zoom in, view full screen. Okay. Again, some of you may be missing a few aspects. Our team is trying to answer those questions. And again, if you make a mistake, we'll do a video on that. Cool. Let's move on. Okay. Oh, this is a nice problem. This is also slightly tricky. Again, some of you are, for the previous problem, some of you are suggesting that 3 states are enough. Please draw the diagram, email us, right? If your answer is correct, we will put it. If your answer is incorrect, because it is possible that such a DFA might accept more strings So please be careful. Remember, this is an MSQ. Please remember, it's an MSQ, which means multiple options can be correct. I told you there are 4 MSQs. This is one. Okay, I'm happy. Some of you are correcting your answer for the previous question. Some of you who said 3, I think some of our teammates said it will accept wrong strings also, and you're correcting it, right? again, in an interactive session like this with hundreds of students, like we have some 317 students right now, it's impossible to see everybody's solution and correct it. So please feel free to email us your solutions. But before you do that, after this session, just think carefully whether your automata accepts additional strings, right? Cool. So what about the answer for this? Again, multiple options, right? Okay, I see a wide spectrum of answers. Again, somebody is saying A, B, C, D, somebody is saying C and D. Please read the options very carefully. The question is tricky because most people will make a mistake in it. Some of you are saying all four A, B, C, D is wrong. Some of you are saying C and D are correct, or A and B are correct, A, C, D are correct. Anyway, we'll construct, again, this is a problem where you have to construct examples very carefully. Somebody has a question here, which is so when it says interpreted as an integer, what it means is, suppose, imagine you have a binary string like this. If you interpret it as an integer, what happens? This is 2 power 0, 2 power 1, 2 power 2, 2 power 3. So 2 power 3 into 0 is 0, 2 power 2 into 1 is 4, plus 2 power 1 into 1 is 2, right? Plus 0. So this is 6. So when you have a binary string, you can interpret it as an integer by converting from binary to decimal, right? As an integer. This is integer representation. That's what it means. Again, please read the question correctly. Please tell me what your answer is. Okay, I see completely like a huge spectrum of options here. Anyway, let me tackle it step by step. Again, I think some of you have mentioned that the previous answer that we gave is incorrect. At least I don't think it is correct. I don't think the answer provided is incorrect at this point. I just thought about it. But if you still strongly think about it, please email us. We will correct it. We'll put in the comment section. Right? We also make mistakes just like everybody. Cool. So let's get into the solution of this. For any problem, that's the same method. Let A and B be two sets of binary strings. A string A, when interpreted as an integer, is divisible by 2. Okay, string in A. right? So what are all the strings in A? Okay, let me write it somewhere here. What are all the strings in A? When interpreted as binary, they all are divisible by 2, which means you have 2. 1 0 is 2, right? Then 1 0 0, which is 4. 1 1 0, which is 6. Then 1 0 0, which is 8, and so on and so forth. Those are the strings that you have in set A. Right? This is what you have in set A. What about set B? Set B is, okay, so divisible by 2 in set A. B, when interpreted as integers, are divisible by 3. So what are all the numbers that are divisible by 3? 3 itself. Then you have 6. 6 is 110. Then you have 9, which is 1009. Then you have 12, which is 8 plus 4 plus 0 plus 0, and so on and so forth, right? So these are the strings that you have. Again, writing some examples will give you a perspective on what's happening. Now it says, let dot be a concatenation operator. Which of the following is false? It's not asking which of them are true. Very common mistake, right? Which of them are false? So let's write which are false, which are true, then we will tick them. Assume that the null string is divisible by n. Perfect. 0 is divisible by every number. Okay, cool. So a string in A dot B, when interpreted as an integer, is divisible by 6. Sorry, A dot B. A dot B means you concatenate, you take one string from A, you take one string from B and concatenate them. Okay. So let's see. So if I take let's take these first ones, right? 1011. So 1011 is a string which belongs to A dot B, because I've taken one string from A, one string from B, the first ones. I concatenated them. Is this divisible by 6? Obviously not, right? This is obviously not divisible by 6. This is 8 plus 2, so this is 2 power 0, 2 power 1, 2 power 2, 2 power 3. So 8 plus 2, 10 plus 1, 11. So 11 obviously not divisible by 6. So this statement is obviously false. So let's write it down. This statement is false. Just let's write that. Second, a string in B dot A, when interpreted as an integer, is divisible by 6. B dot A now, not A dot B. So let's do the first two things, right? 1 1 followed by 1 0. Now what is this? This is 2 power 0, 2 power 1. 2 plus 4, 6. 6 plus 8 is 14. This is also not divisible by 6. It says it's divisible by 6. Right? No, it's not. Not always. Right? So this is also false. This is not always true. Then there exists at least one possible non-empty string. Look at this. This is more interesting. Okay, so this statement is more interesting. There exists at least one non-empty string. I can't use empty strings. I can't use epsilons. There exists at least one possible non-empty string in A and B, such that A dot B or B dot A, when interpreted as integers, is divisible by 6. Obviously, look at this. A is all the multiples of 2. This is all the multiples of 3. So what is the LCM of them? 6. So that's why you have, that's why you have 6 here and you have 6 here also. So if I take this string and if I concatenate them, I get 110, 110. This is obviously divisible by 6, right? Again, you can verify that. This will be divisible by 6. So this is, you can write it as, you can interpret it as A dot B, or you can also interpret it as B dot A. Right? Because the LCM of 2 and 3 is 6. So this statement is true because there exists one possible non-empty string. Again, these strings are non-empty, such that non-empty string in A and B, such that A dot B or B dot A, in this case both A dot B and B dot A, when interpreted as integers, is divisible by 6. Perfectly all right. Right? Next, there exists A and B. Okay. There exist, it should say strings. There exist strings in A and B, such that, oh, by the way, epsilon should be in this, epsilon should also be in this. I forgot that because it says assume null string is divisible by n, right? So epsilon should be there in both. I forgot about that. Again, such mistakes can cost you if you're not careful. So I didn't underline this and I made this mistake. Okay, cool. There exist strings in A and B such that A dot B and B dot A, both, not or, and, okay, when interpreted as integers, are divisible by 6. Yeah, same example. You can take this example because here both A dot B and B dot A, when interpreted as integers, are divisible by 6. Similarly, because epsilon belongs to both A and B, I can take epsilon dot epsilon, right? Epsilon concatenation epsilon, which is epsilon. You can think of it as A dot B or B dot A, doesn't matter, right? because here it doesn't say anything about empty strings. The above statement says non-empty strings. Here it could be empty string. So this statement is also true. Now the question says which of them are false. So A is false and B is false. So you have to tick A and B, right? So that's the catch here. Okay, so I hope this is clear, right? Where is this question? Okay, so I hope this is clear. Isn't that right? Again, I think this question could have been slightly better framed. When I read it again, I see one small confusion. Again, this is what a lot of gate examiners also make mistakes of. So I think they should have said every string. I think they should have just said every string here, not a string. Then it says for all strings, they are divisible by 6, which is false, right? I think in the English phrasing, it would have been better if this was phrased as every string and every string here. Then there exists. So this is like for all. This is also like for all in algebra, right? In your logic, right? This is like there exists, and this is like there exists in your discrete mathematics or engineering math, right? So I hope again the false part. I know some of you made that mistake. Some of you who have given C, D as the answer, you missed reading the false part. That's why this question is slightly tricky. And if I were to go back and rephrase this question, I would have done it as every here. That's a better way of phrasing this to avoid confusion, right? Okay, cool. So I hope this is simple. Again, this is all about, like, somebody's asking about option D, right? Remember, A and B both have epsilons. Epsilon dot epsilon is epsilon, right? So there exists strings in A dot B such that A dot B and B dot A, both of them will be epsilon. Is divisible by 6? Yes, the answer is true. Similarly, if you take 110, 110 is there in A, 110 is also there in B, right? So whether you interpret it as B dot A or A dot B, it is divisible by 6. And there exists at least one string in A and B which satisfy this, right? That's why B is true, and hence we will not take it because we are looking for the false options. Again, I'm speaking slightly fast here just in the interest of time. Please bear with me. Again, I'm very happy that some of you who have seen the second question, who have thought through it in the interim time, have corrected yourself. Others, if you're still not convinced after the session, please reach out to us. Cool. Let's go to the fourth question, folks. Oh, we're already 50 minutes into it. That's okay. That's okay. Oh, again, there is a small thing that I wanted to add here. Here, A is the initial state. That part was slightly missing in the diagram. Let's tackle this. Unfortunately, in the YouTube chat, you can't put pictures because that would help us understand what you're trying to say and answer your questions better. Cool. Very nice question, but I'll answer your question, Chetan. Very nice question. I have made a note of it, Chetan. Very nice question. Very good question also. So what is the answer for this? Some of you are saying, this is an easy question. This is very easy. You just follow the standard steps. Happy to see most of you got it right. Again, this is easy that even if you make silly mistakes, you'll still get the correct answer. We could have tricked it a little, but we thought it's good to have some easy questions so that people don't lose their motivation. Somebody is saying, is there a faster way for minimization apart from minimization table? Again, minimization table is easy with little bit practice. If there are fewer states, it's actually fairly easy. Sometimes it's better to draw them, especially if the diagram is slightly complex and it is taking you time to interpret what each state logically means. Okay, so in the interest of time, I'll run to it. Most of you got the answer right, which is 4. And how do we get it? Very simple. Those of you who are still trying to solve it, look at all the unreachable states. You can never go to E. Remember, from E, you can only go out. You can get into E from F. But then how do you get, look at this. You can't come to H anyway. You can't arrive at H because from H, everything is going out. Nothing is coming in. So you can never reach this. If you can never, again, because this is your initial state, right? If you can never reach H, obviously you can't reach E, F, G, because they all form this tight knit, like again, in this problem relates to something in graph theory, which is cuts, right? Again, I can think of it, each of these as nodes and edges, and then do a cut on the graph. Anyway, so, but in the end, I'll not divert, because the moment I see something like this, it reminds me of cuts in graphs, because that's something very, very powerful concept used, not just in graph theory, but also in machine learning. Anyway, coming back to a discussion here, you can't reach E, F, G, H, so they are unreachable, right? So get rid of them, they're useless. Now look at A, B, C, D. Now, can you minimize these any further? See, D is a final state, you can't combine it with other states. Can you combine A, B, C somehow? Right? So that's the strategy. Sometimes interpreting this diagram gets slightly tricky, right? So what I would suggest you is this. Let's just draw this table quickly. It's not hard, right? You have A, B, C, D. D is anyway the final state. So D, you can't merge it with others. You can merge A, B, C if you can. There are only two symbols, 0 and 1. Let's write it down quickly. 0 on A on 0 is B. A on 1 is itself. B on 0 is A. B on 1 is C. C on 0 is D. C on 1 is B. D on 0 is itself. Sorry, D on 0 is itself. D on 1 is A. Now see what all combinations you can create quickly. Again, you can do this very fast. AB, BC, AC. These are the only ones that you can first try to combine, right? Because you can't combine anything with D. But if you try to combine A and B into one state, see, these two become one state, but A and C are still different. So you can't combine them. If you try to do A and C, look at this. If you try and do A and C, right? Now, if you see this carefully, there is A here, there is B here, but there is D here. So you can't combine them also. Again, we've talked about how to combine states when we describe the minimization. You can't combine AC also. Can you combine BC? You can't combine BC also, right? Because if you combine BC, these two become one state, but still you have A and D, which are different, right? So if you try to do any of these combinations, it will fail, right? Again, this is a standard minimization through the tabular approach. Sometimes you have to do it. The reason this question is easy is because all it needs is get rid of all the unreachable states, apply the standard process, very simple standard process that we all learn about minimizing DFAs. You apply that, you realize that 4 states are needed, you can't go any smaller than that, and you get the answer, done. Very simple. Now, one very interesting point that one of you raised a while ago is logic versus examples. It's a very good question, especially in TOC. Again, logic is something that you build constructively through examples. For example, let me give you this specific example, right? So for this question itself, where is the diagram? Let me just go back to the diagram. So for this question, in addition to examples, we've also built the logic behind what each state is doing. This state is capturing the fact that our string starts with 0 and it has odd number of characters. This state is capturing the logic that it has 0, it is starting with 0 and it has even number of characters. Again, that is the logic part behind it. But that logic part is something that you build step by step. It doesn't happen overnight. And examples is a process through which you can build this. Because examples are easy. It's sort of like brute force. But when you do enough examples, you build the fundamental logic that you need. Obviously, in the long run, logic is important. But for most problems, again, a lot of students ask me, if somebody gives me a dynamic programming problem in top product based companies, interviews, how do I tackle them? I tell them first, do some worked out examples. Because as you solve these examples, you'll discover logic and patterns. Logic is all about patterns, right? And we humans try for most problems, when we are learning, we learn through examples. Even kids do that. But when you solve enough examples, you start building this ability of recognizing patterns and building the logic. So eventually with practice, you will build it. But since we are at the earlier parts, I'm giving you the tools to build the patterns and logics through examples, right? I mean, this happens to everyone. I mean, if I pick up a new area in computer science like quantum computing, or if I study some advanced statistics, the way I understand and get the logic is through examples. We all do that. It's only human, right? So certainly logic is what we need to build in the long run, or patterns are what we need to recognize, but examples are a path to it, a very simple structural path to get into the logic and patterns. Okay, cool. Very good. So let's go to the next question now. Oh, this is an easy question. This is an MSQ. Again, some of you are solving these questions using regular expressions. Great. No questions with that. We have some questions on regular expressions anyway. So certainly a perfect strategy. I prefer drawing diagrams personally. That's why I solve it like them. Okay, let's solve the fifth question now, please. Again, folks, let's focus on problem solving because that's what we are all here for. We have some easy questions just because even in the gate examination, right, you will easily encounter 55 to approximately 55 questions which are actually easy to score. It is like easily 50 marks you can easily score by just tackling easy questions, and the easier amongst the medium questions. Again, this is an MSQ, folks. Please don't jump to the, please, I should have mentioned this. This is an MSQ, which means multiple options can be correct. Please check them. So it says which of the following are true, and we have this grammar. Okay. The starting state is S. Okay, cool. These are the productions. The alphabet is 0, 1. Got it. I should say the starting non-terminal is S. Some of you have made silly mistakes, but some of you are getting it right. Remember, it's an easy question. So if you're careful, you will get it. It's not even tricky. It's straightforward question. You'll see these questions in solved problems, in previous year questions. You'll see all of them. They've just modified it into an MSQ. Some of you have got it right. Very good. Again, even if you're getting easy questions correct or even medium questions correct, tricky ones, if you're falling into traps, you can constructively work out of those traps. Don't worry. It's okay if it takes time. I'm willing to sit here till the time we solve 8 questions and at least spend some time answering your questions. It's okay. Okay, some of you got it right. Some of you are going here and there. Okay, so let me answer it. I think a good chunk of you have tackled it. So let me answer it for you. Okay, so consider the grammar. Okay, these are the non-terminals. These are the terminals. I keep getting confused with the terminology sometimes. These are our production rules. S is our the starting symbol, where P consists of these productions. Okay, cool. Which of the following is or true? We are only looking for true. So we have to go through each of them. The grammar generates all the possible strings from 0 plus 1 plus, which means non-empty strings of 0 and 1. Let's look at it carefully. I always try to draw this tree-like structure, right? So S generates 0S because I'm a visual guy, right? I try to solve all problems by drawing diagrams because it helps me get a better picture of it. So I get, again, I'll take some examples. It is through examples that we can build logic, okay? So 0S, but then my S can also generate just 0. This S now can generate again 0S. I'm just trying to work out a few examples here, right? This S now can generate 1T. Now once we go to T, right? From T, I can't go back to S. I can only keep generating 1Ts. Eventually this will become 1. So if you notice, the strings that are generated here, they start with zeros. That is the pattern that I'm discovering by playing around a little, right? The other thing, suppose if S generates 1T, Now after I reach t, remember the moment I have t, from t I can only generate once, one or more ones, right? So I can also have this, right, like this. So this has no zeros, this has only ones, right? Look at this, this has no zeros, this has only ones. Okay, so this has zeros followed by ones. Now this says that grammar generates all possible strings of 0 plus 1, 0 comma 1 plus. So imagine if I have 0 1 0, it can't generate this, because once I start generating my ones through t, I can't generate zeros anymore. And to generate zeros I need s, right? There are only two non-terminals here, s and t. That is the logic that I've arrived at. That's the pattern that I've arrived at by just looking at a couple of examples. Again, this is the same process. Examples to patterns and logic, right? Somebody asked this very nice question, right? I really loved that question as soon as I saw it. So this is arriving at the logic through examples. Okay, so it can't generate 0 1 0, which is actually part of this language. So A obviously is false, and we are asking which of the following are true. So A will not be ticked, obviously. So A surely not. Now no string in the language contains a substring 1 0. So we have seen in the examples, right? We have seen that once you start generating ones, so you might have some zeros, but once you start generating ones, you can only generate ones. You can't generate a zero after that, which means if you think about it, no string contains the substring 1 followed by 0, because after you have 1, you can only have ones, you can't have zeros. So this statement is true. So B is true, right? Very interesting way of putting it. Now let's look at C. Okay, the language generated by the grammar G is 0 power m 1 power n. Okay, fine. And it says m is greater than equal to 1, n is greater than equal to 2. Not necessary, right? Because look at this. From S, I can generate 0s. This S can again generate 0, which means 0 0 is generated by this grammar. But 0 0 can never be in this, because it says there has to be at least 2 or more ones. Not necessary. Not necessary. So this is surely untrue. Now what about this? Let's look at this. Oh, this says this union this union this. Let's look at what each of them does. It says 0 power m, m greater than equal to 1, which means 0, 0, 0, 0, 0. Yes, you can do that. So because if you keep generating, S generates 0s, and if you keep going, right, if you keep going down, right, so if S generates 0s and if S again generates 0s, so on and so forth, you can generate 0, 0, 0, 0, 0, all of that stuff. So this is true, union, 1 power n, right? So 1 power n. So in 1 power n, what can we do? We can also do that, right? Because S generates 1t, t keeps generating other t's. So at least 1 will be there, but you can have more ones, right? So this is also true. And now look at the third case, which is 0 power m, 1 power n, which is where m is greater than equal to 1 and n is greater than equal to 2. That makes complete sense, because such strings also will be there, right? So this is also true now, right? Because you need to have at least 2 ones. Look at this. Because if you start from S, right, after you have some zeros, so it says at least, so only once, it's already covered in this. So imagine if I have a 0 here, at least 1 0 is needed here, at least 1 0 is needed, right? Then after that, if I have ones, I can only generate 1t, and this t will again have to generate 1 1. So the minimum, if I take this sort of approach, is 0 1 1, right? Or 0 1 1, 4 ones, minimum 1 0, minimum 2 ones. So this is also true. And here we have the union of all three of them. So D is also correct. So B and D are the correct answer. Okay, so cool. This is simple. This is simple. Again, requires you to think through that logic of what each of these non-terminals are trying to generate. This is one way of solving. There is another way of solving, which is through regular expressions, which some of you are recommending in the chat window. Perfectly all right. There is no one way of solving it. There are multiple ways of solving it. I personally prefer these diagrammatic approaches, because by solving a bunch of examples, I can come to patterns and logic. Okay, cool. So, okay, so I think one of my teammates just mentioned that I think there is an answer mistake with this question. I think question 2, right, that we were struggling with. I think the answer should be 3. I said the answer should be 5 if I'm not wrong, or 4. What did I say for this? Let me go back. I said the answer is 5, but it seems there is a way to solve the second question with 3 options. Again, I'll have to work it out myself. Sorry for that mistake. Again, this is the first session we are doing, and there will be some mistakes. We'll correct them in the course of time, and we will write a solution to this and put it. So those of you who said 3, thank you very much, because one of our mentors sat down and tried to work out a solution with 3. Right. So for second question, I think that's the second question, right? Let me just let me do it. So okay, so what was the solution that I put out? Okay, so let me just solve it. No, so thankfully my mentors also had corrected me. Okay, so this is where we got stuck, if you recall. Let me just scroll this a little down. Okay, so here, where are we? Okay, cool. So this is what we got, and it seems you have Q0. It seems it's a second question. Yes, thank you, Subbu. Subbarav is one of our mentors who handles TOC, and thankfully he corrected me. So the correct answer is 3 states, because we can combine. So it seems, okay, let me just draw the, so we have these 3. So let me draw the answer that he just shared, and then we'll correct it. Perfectly all right. 0. We have, he's saying Q1 and Q4 can be combined. Okay, let me see. Okay, and if you have 1, Q2 and Q3 can be combined, and we have 0, 1 here, and we have 1, 0 here. This is what, that's okay, we all make mistakes. I'm also human. So cool. So he suggested that this is the answer with only 3 states. Again, I'm going back to the third question. Okay, so let me see. So what is he doing here? He's taking this final state, combining it with this final state. Again, initial state will keep it as is. These 2 states he's combining. So what is it capturing? Let me just try to digest it for myself, and I'll keep talking, right? So what this state is saying is that you have 0, right? Your string is starting with 0. So this path basically says that you're starting with 0 and you have 1, but if you keep coming back, so 0 followed by some even number of strings of 0s and 1s. That's what it is saying. So other way to reach the final state is this. So this is saying that I can have 1 followed by odd number. Yes, cool. Yeah, so yes, you're right. Those of you who corrected us, you're right. This is the right answer. Again, I'll tell you, I'll correct myself, and the answer is 3, thanks to Subbarav from my team who corrected me. Very good. Thank you very much. Again, I think, again, as a note for myself, let me write the note. The big note for myself is, always when you're solving problems, it's a good idea to minimize it's a good idea to minimize using the tabular approach. Okay, tabular approach. Again, here is a mistake that I have done. I mean, completely agreed. And I have not followed one of the steps that I say, which is draw diagrams and tables. I didn't draw my table. I think that's a mistake. I relied too much on tables and intuition. So I think the mistake that I made, let me also tell you so that you can also learn from it. I'll also learn from it. The mistake I think I made here is I was too stuck on the logic and interpretation of this state. I was too stuck that yes, this is 0 followed by odd, this is 0 followed by even, this is 1 followed by odd, 1 followed by even. How can I combine these 2 states? Because this is capturing a different information, this is capturing a different information. So I was too stuck on the logical part of it, or the patterns that I've discovered, and did not think of the question. The question doesn't care whether you have 0 followed by odd or 1 followed by even. It doesn't care. It just wants you to take to a final state. Once you have 0 followed by odd number of once you have 0 followed by even number of 0 followed by even number of strings, or 1 followed by odd number of strings. It doesn't care that you have 2 states. It really doesn't. And that's why you can combine these 2 states and also combine these 2 states. My mistake. I stay corrected. And I promise you, I will learn from this, and I will use the tabularization approach to combine states to avoid these mistakes in the future. Great lesson. Thanks a lot, folks. Cool. Okay, so let's get back to, again, if there are any errors, do let us know. Again, thankfully our team is also checking us. Okay. Cool. Oh, it seems it's a question from the practice test. I didn't know it. Okay, cool. Okay. It's been a while I solved the practice tests myself, so I didn't recall it myself. I think I should take the blame that I didn't solve the question thoroughly myself. I should have done it before the live session. Cool. I think question 4 is more or less intact. There is no error in this. I think. Again, if you find a mistake, please let us know. Okay, let's keep moving. We are at question 6. We haven't solved this question, right? Let me see. We solved the grammar question just a while ago. Yeah. So the grammar question was the last question. Here is another question. This is an MSQ. Please note that it's an easy question. It's an MSQ. It's always great to solve these interactive problems because when you make mistake, we all learn. When I make mistake, I also learn. There's a nice question in the chat window. I'll write it here. The question here is, how can we avoid going too logically, just like the way you have done right now and made a mistake? Very nice question. I forgot who asked this question. This is by Prashant. I think once we find a logic, right, we get overconfident. The simplest way is follow the steps. Follow the steps rigorously. Like the minimization approach, right? The table-based minimization approach, which is actually a rigorous step-by-step format. I think once we get to the logic or pattern, we get overconfident, including myself. Right? So a better strategy that I should add is follow. This is especially true for TOC, because most of the things just require you to follow steps rigorously, step by step. If you do it, you'll get the answer. Okay, so what is the answer here? Okay, it's a nice question, by the way. While logic is a powerful tool, it can get you complacent and overconfident. Great lesson for today for me. Cool. I think many of you got it right. Some of you messed it up here and there. Okay, so since a good chunk of you have answered it, let me just point to this very nice point that I think Pratyush mentioned a while ago. How to avoid going too logically and making mistakes, just like the way I have done it. I went too logically and I got overconfident as soon as I discovered the right logic. It is follow the steps rigorously, because in most of TOC and compiler design, you have a very nice prescribed set of steps. If you follow that, we'll avoid mistakes. Like without following the steps, probably I could not have figured out logically that, again, probably some of you are better logically than many of us, including me. And probably you could have figured it out, but I couldn't have figured it out without going through the steps rigorously. Cool. So let's tackle this question now. Consider the following languages ABC, A power M, B power N, M not equals to N, okay? A power M, B power N, okay, cool. Which of the following languages are regular, where concatenation, where dot is a concatenation operation between strings in the sets? Oh, we are given these 4 options. It's an MSQ. Cool. Let's answer this. First, let's see which of these languages are regular, right? I mean, we all know pumping lemma, right? So this is obviously regular, right? This is obviously, you can write a regular expression for this, right? So this is also regular. This is not regular, right? This is not regular because you have to ensure that the number of A's is not equals to number of B's. You can prove that rigorously using pumping lemma. Other way to think about it is you need a stack along with a finite automata to be able to say that number of A's and number of B's are not the same, which will lead you to something called as a push down automata, which is the next automata, slightly more powerful. Actually, I shouldn't say slightly. It's, I mean, after you have your finite automatas, your PDAs are the next set of automata which are more powerful. PDA is nothing but finite automata plus stack. And to solve this problem, you need stack. Right? You can easily observe this. Again, those of you who already know what a pushdown automata is, you will recognize this pattern here. Those of you who don't know may not be able to figure it out right away, but you can apply the pumping lemma to discover. Again, applying pumping lemma and proving rigorously is very time taking, but here I'll go with my logic. Okay, cool. So A is non-regular. So one second. So let me write this clearly. So A is non-regular, B is regular, C is regular. Which of the following concatenation? B and C are regular, obviously. So the answer is right. So what does it say? Which of the following languages are regular? Okay, so B and C are regular. So right. Again, I have to make sure. If it just said not regular, I would have been incorrect. B.C. B is regular, C is regular. So you have a concatenation, right? So this is what. So what is concatenation now? So when you have concatenation, you can design the finite automata for this very easily, right? You have the finite automata that accepts language B. You have finite automata that accepts language C, right? So the moment so you have some path to the final state. From each of the final states, connect to the initial state here, right? So again, this is how you construct the automata which accepts B.C. This is concatenation, right? So again, we will learn little later in this whole theory of computation that regular languages are closed under concatenation, because we'll say that, hey, we can build a finite automata that accepts concatenation of regular languages, right? So B.C, regular. So obviously this is also a regular language. A.B.C, no. So you have a non-regular language and you have a regular language. If you combine them, first you have to look at this. How do strings in this look like? First you have A power M, B power M, such that M is not equals to N, followed by some A power M, A power, let's say K, and B power L, such that K is greater than equal to 0 and L is greater than equal to 0. But you can't even determine. So this is how your strings will be in, right? In A.B.C, right? So such strings you can never recognize, because you have to ensure that M is not equals to N. So C is surely not. Similarly D, right? What is D? A.B. Again, what does A.B look like? A power M, B power N, C power K, where M is not equals to N and K is greater than equal to 0. K is not an issue, but M not equals to N is the problem. So this also is not regular, so only A and B are regular. Done. Very simple question. It's an easy question. It's an MSQ. Okay. Cool. Again, there are many ways of solving it. Some of you might solve it through regular expressions. Some of you might go to the properties of regular languages. Again, another very important thing in theory of computation is to know the properties of your regular languages. Because if you just know these properties, right, that concatenation of regular languages is regular. Done. Right? From that, you can easily say B.C is the right option. Right? So in theory of computation, this will become more important as we learn more types of languages, more types of automata. Especially in theory of computation, understanding and knowing the properties is very, very important, because most problems you can solve just through properties. Okay, you'll see that in the future sessions. Cool. So let's go to the 7th question. This is tricky and lengthy. This is an MSQ. I think this is one of the trickiest and lengthiest questions of today. I think I was almost about to make a mistake in this when I was solving it myself. So this is an MSQ. It is also slightly lengthy, so please be careful. Very nice question. Typically, what is the hardness level of MSQs that we see? So MSQs typically tend to be easy or somewhere between easy and medium, right? We have not seen very hard or very tricky MSQs, or you could say MSQs by nature are tricky because it's very easy to make one mistake and lose everything, right? So in general, this is what we have observed, that MSQs tend to be easy or somewhere on the easy medium spectrum, not in the medium hard spectrum, or typically in this range. Again, it's always better to prepare for a slightly harder exam, because if you again have sets next year and one set is harder, one set is easier, you don't want to suffer through that. Very happy to see some of you are getting the answers. Very good. I mean, quite fast actually. I should appreciate that. Again, at the top of the chat window, we have pinned the live session schedule itself, which is on which day, for what topics and what subjects will we have live sessions. Please look at it and prepare accordingly. If you follow us and prepare along with us, by October, we are already done, right? You can go into just pure revision mode after that. I'm very happy to see many of you getting it right. Some of you got it wrong, but that's okay. We all will learn. I almost made a mistake when I was solving this. Some of you got it partially right, but you don't get marks. Suppose, imagine if the answer is A, B, C, and you ticked B and you ticked C. You do not get marks, right? You do not get partial marks. So you have to get all the options correct. There is one very interesting strategy that Subbarao, who is one of our mentors, taught me while solving these types of problems. Because I would solve it slightly differently, but he said, Varma, here is a better way to solve it, or better way to think about solving these problems. I will share that with you. Again, if you are following the order of subjects that we recommended, that is the same order in which we'll do these weekly sessions, right? So if you're learning in a different order, it's up to you. You can watch these at a later time. We'll have them on YouTube. But the order that we have done is something that we thought a lot about, analyzed a lot before we came there. This is not a tough question, folks. This is just lengthy, tricky, and an MSQ, all three put together. But many of you got it right. Okay, so let's go option by option now. Okay, so let's go option A. So RHS is simple, A union B star, which is all the strings of A and B, including the empty string. Let's look at the LHS here. A star B star, right? What is A star B star? Okay, so this is what Subbarao taught me. A star B star, right? So he says, let's write all the strings, or at least a small set of strings. Again, this is solving through examples to get the intuition. So here we can have B. Let's only solve A star B first, right? So this is B alone, then A star B, which means you can get AB, you can get AAB, you can get AAAB, so on and so forth, star. Now, if you observe, all these strings are ending in B. That is a simple pattern that we can recognize, right? All these strings are 0 or more A's followed by B's, right? Simple logic here. So this is one. Now, if you take star of this, again, this is a set, and you can take the star, right? The closure of it. Now, if you take all of this star, what do you get? So this is one part. What about this part? Let's also look at this part quickly. B star A. What is B star A? B star A is A, because B star can be epsilon. Then you have BA, BBA, BBBA, and so on and so forth, right? Star again. So these are all the strings which end in A. These are strings with 0 or 1 B's followed by A at the end. That's it. Okay, I'm just writing it carefully. So we have union of these two. So this star, union this star. So now let's see what is there in the union of this star. So this star, union this star. So from this, again, what is RHS saying? The RHS is saying all the strings, including epsilon, all the strings have to be here. in the LHS, do we have all the strings? Let's think about it. Okay, so do we have epsilon? Yes. Let's start with strings of length 0. Let's look at strings of length 1. A and B. Yes, there is A here. If I just take one value of A, see, look at this. Epsilon is here because this is a star of this, which means epsilon will be here. Similarly, epsilon also will be here. So epsilon is here on the LHS. We know what is RHS. Let's only look at the LHS to avoid confusion. So strings of length 1 can be generated from this. What about strings of length 2? Look at this. Can we generate AA, AB, BA, BB? Can we generate all 4 of them? Let's see. Look at this. Here we have A star. So A star can generate AA. Done. Very simple, right? Now can we generate AB? Yes, there is AB here. If you take one AB, because look at this. This whole thing star. So if I just take one AB once, I get AB. Done. Can I get BA? Yes, I can get BA. Can I get BB? Yes, you can get BB. Because there is B and there is star here, which means any number of repetitions of B. So you can get BB also. Now let's look at strings of length 3. Okay. Again, this is the systematic way through which you can build the logic. Okay. I'm not saying this is foolproof. We all make mistakes. But in general, this is a fairly good one. Can we get 3 A's? Yes. A 3 times. Right. Can we get... again, you can keep iterating through it and you'll see that, again, just in the interest of time, I'm going a little fast. But if you keep all the 3 length strings, you can get that. So while doing this example myself, I said, okay, can it generate AABB? Can it generate that? Like, I just wanted to think through that. Again, if you go systematically, AABB will take some more time before we arrive at that. But if you think about it, we can arrive at AABB, right? Because if you look at this, what is AABB, right? Look at this. I can take AAB from this because it's a star of these, right? So I can take this once and I can take this once and I can concatenate both of them because this whole set has a star, which means I can take AAB once, I can take B once, I get AABB. So any string of length 0, 1, 2, 3, you can verify it for longer strings also, but with a little bit of practice, you'll get used to that, right? This union this, basically what this is generating is, it is generating all strings that end in B. This is generating all strings that end in A because there is a star here. Remember, there is a star here, right? Because of these stars, because your whole alphabet itself is A and B, all you have is strings that end in A or B or epsilon. Epsilon is anyway generated by this, so A is the right option. Again, this is slightly tricky to get your head around this method of trying to work out examples, but with practice, you'll get very good at it, right? Now, similarly, let's try to solve this. I'm not saying this is the only way, but this is the way that I learned and it works very well. It's fairly foolproof. Okay, so what is the RHS here? The RHS here is all the strings of length 0, 1, 2, 3, which consists of A and B's. What about LHS here? Let's look at the LHS now. Okay, so we have A star, B star, star. Now, what is A star, B star, star? Now, let's see. A star, B star. Sorry, A star, B star, star, right? So now, let's see what all strings can be generated by this first. Epsilon can be generated. A can be generated. AA can be generated. Triple A can be generated, so on and so forth. Similarly, B can be generated. BB can be generated. Triple B can be generated. Similarly, I can generate AB, right? I can also generate AAB. I can generate AAAB. Similarly, I can also generate ABB. I'm just trying to work out a few examples here, and all of them have a star. Remember, there is a star here, so you have to put a star here. So now, if you see, you have sigma. You have epsilon, A and B. Now you have a star here. What does it mean? It means I can take A any number of times or B any number of times, including 0 times, which means I can generate all the strings, which means this is equal to A union B star. Look at this. By just using epsilon, A and B, I can generate every string that's imaginable. Imagine if I have just epsilon, A and B star, right? This set is a subset of this, right? By just using AB, taking the star, I don't even require epsilon here actually. By just having AB star, I can generate all the strings which are in A union B star. So this alone, remember, this alone is equivalent to A union B star. Similarly, same steps, you can show that this alone is equal to A union B star. So this is equal to A union B star. This is also equals to A union B star. So what you have here is A union B star concatenated by A union B star concatenated by star, which means any length string of A's and B's concatenated by any length strings of A's and B's repeated any number of times. This is same as A union B star, right? Common sense, if you just try to read it in English, right? So obviously A is a right option. We saw a while ago, B is a right option. What about C? C looks wrong to me because the RHS says A union B star, all the strings. But here you have, look at this, it's very simple if you observe this. What is sigma? What is null set star? Null set star is just epsilon itself. That's all. Epsilon union A star. A star is epsilon sorry, my bad. Triple A and so on and so forth. There is no star. This whole A star I've put it here. Right? This is null set star. Union B, BB, so on and so forth. There is no star anymore. Now, if you take all of this, you have A union B star. Can you generate AB from this? No, AB doesn't belong to this set because you either have A, you have either B. AB cannot be part of this, but AB is part of the RHS. So this can't be the right answer. So, right, it says which of the following identities are equal. So these two are equal, these two are equal, these two are not equal. What about D? Look at this. What about D now? Let's see what D does. D is A star. What is A star? Epsilon, AA, so on and so forth. Triple A, right, so on and so forth, concatenated by, again this is concatenation, right? I have concatenation here. B A star star. Now what is B A star? What will it contain? One instance of B, or it can have BA, it can have BAA, B triple A, so on and so forth, but there is a star on top of it. So there is a star here, right? This is very interesting. Now if you think about it, you have a bunch of A's, right? And again, here I can also have epsilon here. I have B here. I have BA here. Now again, you can go through this step and say, hey, can it generate epsilon? Because the RHS has epsilon. Yes, it can generate. Can it generate only A? Yes, it can generate. Can it generate only B? Yes, it can generate. Can it generate AB now? Now this is interesting, right? It can generate AB because there is A here and I can take this one B here. So it can generate AB. Some of you might think that it's not because remember there is a concatenation here. Right. Similarly, you can go and check that it can generate AA. Obviously, can it generate BA? Yes, BA is already there. Can it generate BB? Yes, because there is a star on top of it. It can repeat B any number of times we want. Right. Again, strings of length 2, you can check for strings of length 3. Take any such string, you will be able to generate it through this pattern. Right. If you need A's at the starting, you use this. If you don't need A's at the starting, you use this and you keep repeating. You're done. Right. So this is equivalent to A union B star. So D is also right, A is right, B is right. So A, B, D, C is incorrect. Again, this is one approach that you can use. Remember the power of star. Star means any element you can repeat 0 or more times. Right. That's it. That's all. Again, this is a very simple, nice approach that you can use. Slightly lengthy. I agree with you. Some of you might be able to solve it using some of the properties of regular expressions. But if you make a mistake there, you're gone. So this example based method is something that I'm recommending to build your logical ability, right? Cool. Very good. So this is tricky and lengthy. I completely agree. I think I have taken about 5 minutes to 6 minutes to solve this problem when I was solving it before the live session. So, and I have not practiced TOC much. Hopefully with practice, I'll also become better at it, just like all of you. Cool. Let's go to the 8th problem now. This is an easy problem. So the whole problem here. This is an easy problem. It's an MCQ, fairly easy. Okay, the last problem of the day. I know some of you may be slightly tired. That's okay. We should be able to sit for 1 hour and solve. We are already at 97 minutes. That's okay. Let's sit on it. Again, it's not that you're constantly solving problems, right? I'm also explaining back and forth. There is a small trick that you can apply for problems like this. I'll tell you that. The previous problem is certainly lengthy and time taking. I completely agree with that. Oh, somebody says none of the options. Actually, I didn't check the whole answer myself, to be honest with you. Probably none of the options is correct. I just looked at the options and I picked the most appropriate one by elimination. Okay, let me solve it myself then. We'll solve it together anyway. Maybe none of the options is correct. I just eliminated to solve this faster. Okay, imagine this question was given in GATE. What would be the most appropriate choice given that it's an MCQ? Okay, so some of you were saying that none of the options are correct. Imagine if this was given in GATE, what would you pick? Okay, some of you are saying D, some of you are saying A. Okay, why is it D or A? Anyway, let's solve it together. Again, this problem statement, typically in GATE questions, they would clarify better, and they could say that, I mean, imagine one more statement is given here, that ignore the output of the initial state. Output of the initial state. Imagine if this is added, right? Typically, such clarifications are sometimes given. Imagine we add this clarification that please ignore the output of the initial state, which means at the very beginning you are at state A, whatever output it generates, just ignore that. Now solve it. Imagine if this clarification was given, because in GATE sometimes such clarifications are given to avoid these mistakes. Again, while setting up this question, we assumed that we ignore the output of the initial state. Okay, now let's solve them. I'm just writing it up here so that I know what everybody is thinking of, but let's assume this clarification is given. Okay, some of you are getting a completely different answer even after you ignore the output of the initial state. Okay, got it. Anyway, let's answer this, right? Let's go step by step and answer it. Okay, so so what do we have here? We have so we are starting with A. I just typically try to draw these diagrams first. So the moment I saw these options, right, I realized that the first strings are more or less the same. So what matters is the last 3 or 4, because that's where all these differ literally, right? All of them differ in the last 3 or last in the last 3 strings or 4 strings. So if I get the last states, the outputs corresponding to them, I can just eliminate the rest and solve it. That's how I thought about solving it, right? So first, instead of going through each state, I'll just draw it. So we are at state A. Let's assume there is no output generated when we are at the initial state. From A, what do we have? We have string, so we go one by one. A on 0, what does A on 0 go to? A on 0 goes to A. Okay, just correct me if I'm making any mistake. Then on 1, so then A on 1 goes to B. Then B on 1. Again, you have to do it slightly carefully not to miss it out. B on 1 goes to C. Again, I'm not even saying what is output here because we only care about the last few bits, right? So, okay, so then I have 0. C on 0, where do I go? C on 0, I go to D. Now, D on 0, right? So D on 0, where do I go now? D on 0, I go to A. A on 1, I go to B. Okay, cool. So B on 0 next. Okay, B on 0 is E. Okay, cool. B on 1, sorry, E on 1 now. E on 1 is F. Okay, I hope I'm on the right track, but let's see. So then on 1, because one mistake, everything goes for a toss. F on 1 is C. So then C on 0, so C on 0 is D. D on 0 again, so D on 0 is A. So now let's look at the outputs that are generated here. In state A, our output is 0. Again, we have to go in the reverse order. So the last output bit will be 0. So D can't be the answer, first and foremost. Then we have D. What is output at D? D output is 1. So let's write 1 here, right? So 0 and then 1 before that. So this can't be the answer, right? Even this can't be the answer. The only valid option which will generate, see, if you read it backwards, right? 0 followed by 1. 0 followed by 1 is only there for option A. It's not there for option B, C or D. So option A automatically, right? Automatically option A. Of course, I'm doing this because I know that it's an MCQ. I can eliminate other options. Now I can obviously go back and write for C, what is the output? 0. For F, what is the output? 1. For E, what is the output? 0. For B, what is the output? 0. For A, what is the output? 0. For D, what is the output? 1. For C, what is the output? 0. This is like a kid's exercise, but that's okay. What is the output for A? 0. Initial output, let's assume it's not there. Again, depending on the textbook that you're reading, some textbooks suggest that at the initial state it generates an output. Some textbooks and articles and Wikipedia say that you don't have to generate. So that depends. So that's why very often for questions like these, there could be clarification given by the examiner. But even if clarification is not given, pick the most appropriate answer. In this case, A. That's it. Very simple. Because if you pick A, you're most likely, again, the examiner could tomorrow say, hey, we assume that you know by default that you can ignore the output of the initial state. That's a very common practice. If you don't believe me, refer this textbook, right? So if they say that, then you are not at loss, okay? So because it's an MCQ, it's a smart choice to pick A, right? Cool. So I think we have solved these questions. There are some important and interesting takeaways for all of us, including me. So let me just change the screen and go into the chat window, because I promised you that, just give me a second. I'll open the chat window on my phone. As I promised you, I'll spend some time on general Q&A. So let's go into that. Okay, cool. Again, it's okay. We all do mistakes. Like I made the mistake in second question. I should have cross-checked it with my team. I think I was overconfident in the logic. Okay. But anyway, thanks to students like you, I learn. And my biggest takeaway today is don't skip the steps. Okay, cool. So any questions you have, feel free to ask me. I'll try to answer as many as possible in the next few minutes. So this is by Subarno, a very good question actually. So Subarno says okay, let me just close my, okay, I don't think, okay, so give me a second. I'm just trying to see the comments here on my computer itself so that I can better answer them without looking down. But Subarno says in the practice tests that we have in the course, after we solve it, should we just go and see the answers? My suggestion is this, Subarno. This is what we always suggest. So suppose you've solved the questions, you got them incorrect. Instead of going to the solution, try to figure out what mistake you have done. If you have done a silly mistake, or if you have a conceptual, if you can figure it out on your own, nothing beats that, trust me. It's one second, I think I made a mistake somewhere. Is everything okay? Okay, cool. Yeah, so I can see myself. Cool. So when you're solving your practice questions, if you've made a mistake, please go back and try to debug it yourself. Because nothing better than figuring out yourself that you've made a mistake. Like question 2 today. I figured out, thanks to people like Subara, who are our mentors, who have helped me figure out, and thanks to students like you who said, no, the answer is 3. The moment I learned my mistake, I will never forget it now, or at least I'll try not to forget. I'll surely make a note of it. So same process for you. We all are human. So if you have not got an answer, please try to struggle for at least a day or 2, try to figure it out, try to attempt it 2-3 times. If you still can't get it, go to the answer, check the answer and make notes of what you're lacking, or go back and revise. That's perfectly the process that we recommend. Cool. So Ramakrishna says how to be disciplined. I'm taking random questions here. He says how to be disciplined. There is a video on our YouTube channel which is how to be persistent in gate preparation, which we launched maybe a month ago. Please check it out. These are very, very, very practical steps from actually phenomenal research that we recommend. Please try to follow that. It's about habit forming. How to make revision entertaining and fun. The best form of revision is, like, this is what I have done. Okay, so before this TOC sessions, I take the notes that we have on our website, which is freely available to everyone. I just went through the whole notes. I quickly skimmed through it in just a few hours, and then I went ahead and solved problems, like the problems that my team has set up, right? So quickly revise the notes that we have given you, or you have made, or small annotations that you've made in the notes that we have provided you, and simply practice through revision. That's more fun. There is nothing better than problem solving. It's very satisfying at the end of the day. Okay, so please try to do that. What is the best book for theory of computation? Actually, we are compiling a list of books. We'll put out a video on that in the next couple of days. For theory of computation, okay, let me share the screen. Okay, there is this phenomenal book. So this is, which is what we used ourselves by. Of course, it's by Ullman, but it's by Ullman and one second, recent edition. Just give me a second. It also has this professor at Stanford. I keep forgetting his name sometimes. Sad that I forgot. Rajiv Motwani. Yes. So there is this. Okay, there is this recent edition, or I can't call it recent because it's been there from 2007, right? Because I read this book, I read the newer version. There is an old version of this book by Hopcraft and Ullman, phenomenal researchers in computer science in general. But there is a re-edit written by Rajiv Motwani. For those of you who don't know, Rajiv Motwani was one of the early investors in Google. He was the mentor to Larry Page and Sergey Brin. Phenomenal professor at Stanford. He has like great books and great fundamental contributions in algorithms. So I think Rajiv Motwani took the book that Hopcraft and Ullman have written for almost a few decades now and modified it into language that is easy to read. So if I have to pick one book, this is my favorite book. I read this book the first time in my BTech 3rd year. I think I have a copy of it somewhere in my home or in my parents' home. It's one of the best books I can recommend. Again, it's not just the regular Ullman Hopcraft book. That is very hard to follow. Please make sure it has Rajiv Motwani as the co-author. Again, a lot of our course is created based on this textbook. This is one of the best that I know of. Cool. Very nice question. This is by Ira Asmani. A very nice question. I'm happy you asked it. So Ira is a female name, if I'm not wrong. Yes. So Ira says, I'm getting about 50% marks in mock tests. How to improve score along with time management? I think, Ira, you meant practice tests. So in our practice tests, the first time you're attempting them, if you're getting 40-50% marks, that's actually very good. Because you can go from, what is 50% marks roughly? It is 50 out of 100, right? Which is not a bad thing at this point of time. You just have to debug your mistake, go through the live session that we have done on how to improve your problem solving methods, revise more, solve more problems, but solve them in the process of debugging where you are having gaps, right? It's not just volume that matters. It is the process of solving that matters and the process of improving that matters. Once you do that, we have seen a lot of toppers who used to get 30 marks, 30% mark, 35%, 40% marks in GATE practice tests last year. And by the end of it, they were rocking. They were getting like 70 plus marks. Okay. So Rakesh says, is the notes that you provide sufficient or should we make your own notes? If you don't have time, don't spend, like if you are a working professional or if you're a student who do not have time, it's okay. Take our notes. This is what a lot of students do. They print it or they have it on their phone and they just write annotations on top of it. Right? They just say, hey, this is the detailed notes, but these are the only things that I should care about. Like you can get them in PDF format on your phones or iPads or printed versions. They just highlight what they care about. They make their own personal notes there. Right? That way, you don't have to write the detailed notes. You can annotate on top of the notes that we provide, and that would be sufficient for your revision. But if you have time, writing your own notes is unbeatable because you're writing in the, we've seen a lot of students who write their notes in their mother tongue because that's what they understand better. They draw diagrams that they can correlate, they can think through better. Like my notes will be very different from your notes because I write it in the fashion that I can understand better. So if you have time, do it. If you don't have time, that's perfectly okay. So Vikas says, I'm not good at memorizing the short terms. How to improve it? Now, what do you mean by short terms like DFA, NFA, etc.? Just write them in your notes, right? Again, as far as revision strategy is concerned, this is what we revise. If you use the terms more and more, you'll get comfortable with them. We all do, right? Like just like our, why are you comfortable with some words in your mother tongue? Because you use it every day. Same thing here, right? So as far as revision is concerned, this is what we recommend. Go through the concepts, solve the practice questions at the end of that chunk of concepts. We also have topic tests from GATE Test Series 2021. Solve them if you have time. So your weekend revision should be everything that you learned in the week. Your month-end revision, because in a month you can easily finish about 1.5 subjects. Everything you've learned, all the subjects that you have completed, take subject tests from GATE Test Series 2021. Test Series 2022 will be available next month, right? June it will be available. So you can use that in your next preparation also, right? So every weekend, every month end, every quarter end. Quarter, for those of you who may not know, who are not working professionals, is end of 3 months. If you do this, I think you're comfortable. 3 revisions by October, November, maybe even by December. If you finish everything, you still can do 1 or 2 revisions in the last couple of months. Okay. So Rahul says, I'm a diploma holder. Very good question actually, because there are students who take diploma and then come to engineering second year directly. But Rahul, engineering maths, which you learn, like your calculus, etc., that some of the diploma holders may not know, that's actually very low weightage. The most weightage comes actually from discrete mathematics, right? And that's what probably you learned in your undergrad also, right? In your second year. So for maths, which has a considerable amount of weightage, you have to learn the concept, no escaping that. Of course, if you're not very, like calculus related problems, you get maybe 1, maybe 2 marks. If you are like, if it is becoming too burdensome, leave it, but rest everything you should learn. Okay, you can't escape that because it has a considerably good weightage in marks. Again, by the way, those of you who have to leave because we're already close to 9 p.m., we're already 2 hours into it, please feel free to leave. I'll answer a few questions and then take a break myself. So Rakesh has this question, which is how to manage time for preparation and job. We're just making a video on that. We'll put it out. But in a nutshell, it is this. Even if you have a job, I mean, I have a job. I used to have a job, not a startup job, but a regular company, but still could put in time. Like we had a very hectic schedule in my previous company, but in most 99.9% of companies, you can still allocate the early morning 2 hours before you start working. That's a great time. Get disciplined about it, make it a habit, put in those early 2 hours. Throughout the day, just like the way you take chai breaks at your office, or since you're working from home, chai breaks, during those chai breaks or whenever you're taking break from your regular work, try to revise whatever you learned in the morning, and at the end of the day, spend maybe an hour, solve problems, right? I think you have to stick to this 3.5 hour schedule. Stop all social media. If social media is important for you, that means probably gate is not important for you, right? So please stick to that. You can easily squeeze in 3 hours if you remove all social media, all television, all the useless stuff in your life. 3 hours, I think 99.9% of working professionals can squeeze in. You got to get disciplined. If you want to stay in the job and prepare, you got to put in extra effort. Simple. Sumit has this is a question that a lot of our students asked, and we're again making a video on this, which is how to go from rank 4000 to less than 500. Simple steps. Again, I'll summarize it. Figure out what areas and what topics you're lacking, what problems you're not able to solve. Focus on those first. Because from my gate, in my third year, I wrote my gate exam. I got a rank of 176 or 178. I don't remember that last digit well. So in my fourth year, when I again retook the gate exam, all I did was I said, these are the subjects that I'm not good at. I'm going to double down on them. Like I was very good at math. I was fairly good at data structures, algorithms, but there were subjects like computer networks because I didn't study them because we didn't have that subject till fourth year, right? So in my fourth year, all I did was first I focused almost 50% of my time on topics and subjects that I'm not comfortable in. 50% of my time on the rest of the topics. That's it. You do this, you have to recognize what you're lacking and double down on those, and that's it. You can easily, like we have seen students who got 3000, 5000 rank, we've comfortably gone below 300. Simple techniques, nothing very fancy or rocket science here. Cool. Again, so this is Alpan. Alpan says, what is the correct sequence of studying concepts, practice, and test? That's what I said, right? Every day, try to spend, at least at this point of time, try to spend, because you have to first learn concepts, try to spend 70% of your time on learning concepts at this point, 30% on solving problems. Every weekend, take a topic test or take a practice test, solve the problems, even solve problems that we have in the course videos. First, try to tackle them before you see the solution that we provide. We have thousands of problems that are already solved in the course videos. But before you see the solution, first try to tackle it yourself. Because that's a form of discovering what you understood and what you did not understand, right? So please try to do that. Again, simple. Week long, 70% or 2/3 of your time on learning the concept, 1/3 on practice. Weekend, mandatory revision, mandatory taking the practice test or the topic test. Month end, again, revise, take the whole subject test. Quarter end, if you have finished 3 or 4 subjects, revise, take the tests. That's the cycle that you got to follow. So Aman says, how to get first rank in GATE for 4th year students? I do not know. I mean, I'm being honest with you. Because to get the first rank, you got to get slightly lucky. I mean, that's the reality of it. The difference between first ranker and second ranker often is just one question. So instead of asking that question, I think that's an incorrect question. That how do I get first rank? Ask yourself, how do I be in the top 50 ranks or the top 100 ranks? Right? That basically means that you have to get 70+ marks. And whether you get rank 1 or rank 10 or rank 20 or rank 30, all of you will get the same opportunities. It really doesn't matter. Nobody cares what my gate rank is beyond a certain time. Like I have some of my classmates whose rank is 30. I think the last rank in my class was 31 at IASC. That guy is doing phenomenally well. It really doesn't matter whether you're 2 or 1. So don't aim for 1. Try to aim for that top 100, because if you're in top 100, most likely you'll get into all the top universities of your choice. Cool. So this is Ravi says, it takes much time to cover concepts, like 1 hour content takes more time. How do I tackle it? Again, ask yourself, why are you taking more time? Because the videos have been explained very, very slowly. Actually, a lot of our students actually watch the videos at 2x speed, right? So ask yourself, what is it that you're not able to grasp? Again, don't waste too much time. Just go through the video once at 1x. A lot of students watch it at 2x. We even have 3x in our videos because students say, hey, I know this concept partly, but I want to just go through it quickly, right? So watch it, but don't spend too much time stuck on one concept. Solve the problems that will give you the confidence and keep moving on. Don't spend like 2 hours, 3 hours on just 1 hour of content. That's not worth it. You should be able to move faster, but to move faster, you have to ask yourself, why are you getting stuck there? That's the important question. Is it like you're not understanding what is being taught, or you have some conceptual gaps for other subjects that you may not know? Because in most of our videos, we try to cover every subject from scratch without making any assumptions of other subjects. Again, do reach out to us over email so that we can debug where you're getting slowed down and help you through that. Okay, so how to practice math problems? So which math problems are we talking about? Again, if you're, there are literally thousands of, if you just Google search for gate problems, you'll get thousands of these problems. There is no limit to it. But what we have done is in our course for practice tests, mock tests, test series, all of that, we have curated these so as to give you a wide variety of problems, easy, medium, tricky. We have designed a lot of MSQs. So think of our test series as something that we have curated from all the good resources, mostly from textbooks and top university exercise problems in midterms and final semester exams, and some of them that we have created from scratch. Like you won't get it if you Google search. So we have tried to create this set primarily as a way to expose you to a wide spectrum of problems, right? So again, if you want to simply practice, there are thousands of questions. Previous year questions could be a good start, right? If you want questions, that's a great start. If you go to the last 20 years of question papers, there is a terrific resource. Okay, cool. I think some of the questions I've answered in the previous live sessions, etc. What is this here? It says, how many subjects should I study in parallel? Do one at a time. Of course, there are people who do 2 or 3 at a time, but you might mix up things. Unless you have a very good ability to shift from one topic to other topic, or unless you have a very good skill to multi-process or parallel process things, which I suck at. Like I can't even read the comments and answer your questions without getting distracted a little. So at least my personal suggestion, we have some mentors who do 2 subjects, 3 subjects. We have done 2, 3 subjects simultaneously in their own gate prep. But my suggestion would always be do one subject, do it thoroughly, move to the next subject. Of course, you can do related subjects one after the other. Like you can do TOC followed by CD, right? You can do data structures followed by algorithms, right? So that's a better approach. Okay, cool. So I think it's already 9:06. I've already spent over 2 hours. Thank you very much, folks, and all the very best. Again, please look at the pinned the Google sheet that we have, which tells you what is the schedule of the next live sessions. Again, to be clear, some of these live sessions will be public, some of them will be private, only for our course enrolled students. All the very best. Bye-bye.